All right, welcome back. In this part, we're going to talk about how we measure digital signals. So usually in a digital audio workstation, digital signals are going to be measured in dBFS, decibels relative to full scale. And what that means is we have that maximum possible value that a signal can be with digital PCM encoded audio. And so we usually measure relative to the maximum possible value, where the loudest value you can have is 0. And because of that, all of the relative values are negative. So instead of using the threshold of human hearing as a reference, we actually use the loudest possible signal as a reference. And then we measure negative from there. So this is the mixer and Reaper showing the levels of the audio tracks of Duvet. And they're measured in dBFS. So these numbers up here are in dBFS, and these numbers over here are in dBFS. So some notes about reading these. You don't need to memorize this. You'll get more experience with it as you mix and master things in Reaper. But up at the top here, you have the absolute peak. So that's useful to see if your track is clipping, and like how loud it possibly gets at any instant. And so as the track is playing, this will update if it goes above that number. And you can click it to reset and measure a different part of the track. And then there's 2 bars for each track. One's going to be the left channel, one's going to be the right channel if you're working in stereo. These bars here are the peak level of each channel over the last second. And then the bars that move around more are the instantaneous levels. Notice here how the master channel and the reverb channel are the only 2 channels in stereo. Now that's just a guess based on what this looks like and because I know the project. But I can tell that that's probably the case because the left and right channels are different for those 2 channels, whereas everything else, the peaks are the exact same and the instantaneous level is the exact same. So I can venture a guess that they're probably in mono. Now, dBFS is useful, and it gives us a rough approximation of how loud something is. But loudness is a subjective human feeling, and so it can't be quantified exactly. But there's ways to approximate it better than just dBFS. And what we can do, we can take into account the fact that humans perceive certain frequencies of the same sound intensity to be louder than others. And we can define some ways for actually measuring loudness. Because dBFS, you can also look at various averages. You could look at the peak. You could look at the average over a certain amount of time. But the LUFS unit, that's loudness units relative to full scale. So again, 0 LUFS is going to be the loudest you can get. It takes into account the human perception of different frequencies. And then it also defines 3 averaging windows. LUFS M is momentary loudness. That's almost instantaneous. It's averaged over 300 milliseconds. LUFS S is short-term loudness. So that can give you a good idea for how loud a certain part of a track is. And that's averaged over 3 seconds. And lastly, we have integrated loudness, LUFS I. And that's the average loudness over the entire track. So this is the curve that the LUFS unit uses to weight different frequencies. And you can see here that humans don't perceive bass to be very loud, but we perceive higher frequencies to be louder than mids. And here's an example of a render of Godzilla Suite 2 in Reaper. And here we can see the LUFS I measurement. So this entire track, if you take the average loudness, it has a LUFS I of -14. So before we keep going on, I'll have this video next in the playlist, and this is going to talk a little bit more and give some context for loudness.